Here we got the exact solution for the weight. And next step, we need to get the exact solution for the B. And we still from the first equation. So we start from here. Minus I equal to 1 to n and di, and then plus I equal to 1 to n and w xi, and then plus I equal to 1 to n and b equal to 0. This is the equation 1. And here what we do is we move these two terms on the right side, and we can move the w out of the summation. So from here we got the w, and then I equal to 1 to n and xi equal to, this one move to this side, this equal to summation I equal to 1 and n and di, and then minus, here is total nb sum together, that's minus nb. So here we can get the w, so w equal to nothing but equal to the summation of di and the minus nb and over summation of xi. Okay, we got this equation. We got the 3. We got the w. So now next step is we plug 3 into equation B, equation 2. So this is equation 2. We plug the w into this equation. Replace the w with the equation 3. Now what we got is, we got this. And here's di and xi, and then plus, go back to equation 2. So here's w. We use the w, equation 3, to replace the w. And the plus w equal to this guy, d, and the minus nb. And here is xi. Of course, here's I from 1 to n. And here is di, I is from 1 to n. And then multiply with I from 1 to n, and here's the xi squared. And then plus b and xi. Of course, all summation is I from 1 to n. We didn't write it here, but here's I from 1 to n. Here's I equal to 1 to n. So this whole thing equal to 0. And we reorganize everything. So here equal to di, xi, and then summation xi. We multiply this term on both sides, and then plus summation di and minus nb, and then this is the I from 1 to n and xi squared, and then plus b, I equal to 1 to n. Here's xi, and then we multiply this term. We emphasize this term using different color. So what we do is we multiply this term on every term in this equation. So first term becomes to this because it's multiplied this term. And second time, eliminate this denominator. And third term equal to this guy, and then multiply with another term. Summation I equal to 1 to n, another xi term. So this whole thing equal to 0. And then is equal to minus summation di, xi, and summation xi, and then plus this guy multiply this guy. Summation I equal to 1 n, and then it's the di. Summation I equal to 1 to infinity and xi square, and then minus nb. Summation I from 1 to n and xi square, and plus b I equal to 1 infinity xi, another term. Okay, here has b. Let's mark all the terms with b. So here has b terms, and this term has b. So we know b is a constant. We can move the b outside the summation. So this one equal to b equal to this term sum together, and then move this part to right side and then over this. So this equal to summation and di xi and summation xi, and minus, because this one move to right side, it becomes to minus side becomes positive, positive side becomes to minus side. So this equal to I equal to 1 to n and di, and then summation I equal to 1 to n xi2, and on the denominator equal to this term and plus this term, that's equal to summation xi, and then summation xi, that's with this term, and minus n, and then summation I equal to 1 to n, and then here's the xi square. So let's keep working on this. So here b equal to summation di and xi and summation xi, and then minus the di xi square, and over here is n. Look at it here. Here has n terms. There's no n terms, but what we do is we multiply with n term, multiply with n and over n. So this is what we do is n, and then here is 1 over n and the summation and the xi, and then multiply with xi and minus n summation and xi square. So this is just these terms. And then what we do is look at this term. Look at these whole terms. This is nothing, but this one equal to x bar. So now we put this one, we use the x bar to replace that term. This one going to equal to, the b going to equal to summation and the di and the xi and summation xi, and then minus summation di and the summation xi square, and then here equal to d, you can move the n total out. So here's x bar multiply with summation xi, and then minus summation xi square. Okay, now we got to the b, the exact solution for b. Okay, this is the final equation for B and for W. I call this exact solution for B and for W. Okay, very complicated equation. Okay, we can use this one to find the W and B. There's no problem. We can do that. But go back to this example. We only set a very simple neural network, single input, single output, single neuron perceptron. Okay. Even for such this will be the simplest neural network. You got this equation to find the W and the B. To be more realistic, this method can give you an optimal solution, or I can call it the exact solution, but it could be time and memory consuming as a batch solution. It's only for a single input, single output is such time and memory consuming. If you have multiple input, for example, you have 100 input, basically this almost impossible to solve this equation. So we have to figure out a better way to do this, to solve this, or to figure out a better way to get the optimal synaptic weight.